Hello and welcome to this video in the R course. In this video, we will look at the application of the chi-square test in R. As seen in a previous video, chi-square test is used for goodness of fit. To recall a little, this test is used if we have a set of data at our disposal and then we want to predict the distribution it follows. For example, if we roll a die 500 times and look at the observed frequency of the results and then compare it to the uniform distribution to see if the frequencies observed follow the uniform distribution or not. This kind of test is always one-tailed. Chi-square test can also be used to test for independence. This test is conducted when we have to test for the presence of certain attributes which are qualitative in nature. For example, if we have a pool of 1,000 students and we want to categorize them into 4 groups, namely smart and intelligent, smart but not intelligent, not smart but intelligent, and neither smart nor intelligent. To see if there is any association between these two personality traits, we conduct a chi-square test on the basis of the frequencies generated in these groups. Let us take an example to understand the use of chi-square test for goodness of fit. Suppose we have various mobile stores across the country selling mobiles of different brands. We have the data here for the company, store region and the number of mobiles sold. When we summarize this data based on companies, this is the output we get. 27.46% of the phones sold were of Samsung, 15.55% was Nokia, and so on and so forth. Finding out the percentage in an Excel sheet is something we have seen in our Excel course as well. Thus, we have the population distribution here. 27.46% of the phones sold are Samsung, 15.55% are Nokia, etc. Now we will take the data of a particular store and check if the sales trend of the store is similar to that of the population or not. We picked up some data from the store randomly to conduct the test. This is the data we picked, and upon summarizing, the observed sales pattern for the store came out to be this. Samsung has 427 units sold in the sample, whereas in the population it was 1909. But the value of interest for us is the percentage of units sold. Before we go ahead to look at the test statistic, let us define the null hypothesis. The null hypothesis is that the store belongs to the population and hence has the same sales trend as the population. Hence, it is a good fit to the population. Now, let us check that. We will calculate the observed percentage of sales for each company like we did for the population data. The value of these figures should be similar to the population data since we believe that the sales trend of the store mirrors that of the whole population. As we calculate the percentages, we can see that they are not exactly the same as that of the population. But are they significantly different? This is the question we need to answer through the chi-square test. We can see that the values for all the brands are slightly different from the population distribution. We have already seen the formula for this in our previous video. The test statistic is summation of squared differences between observed and expected frequencies divided by expected frequencies. To calculate the expected frequencies, we just copy paste the values from the population tab. This should have been the distribution if the null hypothesis is true. We name the two variables as observed percentage and expected probability. Now we will calculate the expected frequencies by multiplying the total number of units sold with the respective percentage value for each of the brands. We can see, as expected, the sum of the observed units and the sum of the expected units is the same. Now we have the observed and expected frequencies. Let us now put the values in the formula to get the test statistic value. As we find the sum, we get a value of 22.1586. This is the calculated value of chi-square here. Let us now look at the chi-square table to check the tabular value to see if the null hypothesis is rejected or not. The degrees of freedom will be k-1 as mentioned in an earlier video. And since we have 9 companies, thus the degrees of freedom is 8. Remember, had we estimated any parameter, then we would have lost more degrees of freedom. In the table, we have been given greater than values for chi-square. So at 5% level of significance, we check for the value corresponding to 8 degrees of freedom, which comes out to be 15.507. Therefore, the calculated value is greater than the tabular value. Hence, we reject the null hypothesis. This means that the sales trend of the store does not match the sales trend of the population, and hence this is not a good fit. We could have used the formula of chi-square test in Excel instead of calculating these values. We can see that it requires just two arguments, actual or observed range of values and the expected range of values. As we press enter, we get the p-value for the test statistic. The value comes out to be 0.463%, which is less than the level of significance, which is 5%. Hence, we again reject the H0. Let us now see this in R. We have already imported this dataset in R. We have the company name, observed frequency, observed percentage, and expected probability. This is the command we passed to import the dataset in R. Please remember to install the XLSX package to import or read this file. We have mentioned the sheet as sheet 3 because the table is saved here. We have named this sheet as observed in our Excel file. When we conduct the chi-square test in R, we require two things. These are observed quantity and expected probability. Please ensure that the sum of the expected probability distribution is 1 to avoid any errors. We write chi-square.test, then in brackets x is equal to store data. This is the observed frequency, and then p is equal to expected probability. The moment we press enter, we get the result for the test. We can see we get the chi-square test statistic value of 22.159, which is the same as we got earlier. The degrees of freedom is 8 and the p-value is 0.463%. If you remember, we had seen these values in our previous video of test of two proportions also. Even there, the null hypothesis was rejected. Hope it is clear now as to how we use the chi-square test in R. This is it for this video. Thank you.